So these notes cover rational exponents. So if you remember from the activity in class today, if you have an exponent, it's a fraction, so the exponent, we'll start with 1 over n. 1 over n indicates the nth root of a number. So for example, 16 to the power of 1/4 is the same as having the 4th root of 16. And the 4th root of 16 just asks what number raised to the 4th power gives me 16. And that would be 2, because 2 to the 4th equals 16. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Now, if we change the exponent to have a numerator, so I'm just going to switch this around. The exponent m over n indicates the nth root raised to the mth power. So, for example, 8 to the power of 2/3 is the cube root of 8 to the 2nd power, right? So the denominator becomes the index for the radical, and the numerator becomes the exponent. And the cube root of 8 is 2, so this is 2 squared, which we know is 4, right? More generally, some number a to the power of m over n is the nth root of a to the nth power. Now it's important to note that the order that these happen in does not matter. So we could also say this is the same as a raised to the mth power and the nth root of the whole thing. It's the same thing. You'll get the same answer. We'll do an example to demonstrate. So let's say we want to evaluate negative 125 to the 2/3 power. Now the first thing I want to do is I'm going to write this in radical form. So this is the same as negative 125, the cube root of negative 125, all squared. Now remember we said it doesn't matter what order we do this. So what if we also did the cube root of negative 125 squared? You can see how it has the advantage of writing it both ways. This one's going to be easier to work out because I don't know what negative 125 squared is off the top of my head. But I do know the cube root of negative 125 is negative 5. Because negative 5 times negative 5 is positive 25, but then times negative 5 again would be negative 125. So this is negative 5 squared, which of course is 25. Now here, if you grab your calculators, negative 125 squared is 15,625. And the cube root of 15,625 is 25. So in this case, it was a lot easier to evaluate the radical before the exponent. But sometimes it's the other way around. So let's do a few practices. So let's write these using rational exponents. And we'll have a few radical expressions. So we have fourth root of 7 to the third power. So the base stays the same. It's going to be 7. I have my fraction here. The exponent is the numerator. So I'll draw an arrow. Exponent is the numerator. And the index here is the denominator. So this is the same as 7 to the 3/4 power. One way that helps me remember which goes where is I think an exponent makes a number bigger. So the part that makes it bigger should have to go in the numerator, because the numerator is what's going to make a number bigger. Bigger numerator means a bigger number. A radical makes a number smaller, right? So if we have a radical, then it makes sense for the radical to be a denominator, because a bigger denominator means a smaller number, right? 3 over a million is less than 3 over 4, right? Let's do another one. 11 to the 6th power and the cube root of that. Again, exponent is the numerator, so we have 11 to the 6th, and the index is the denominator, so 11 to the 6 over 3. Now, what do we know about the fraction 6 over 3? It simplifies, right? So this is the same as 11 over 6 over 3 simplifies to 2 over 1, or just 11 to the 2nd power. And we know what this is. That's 121. You should know what that is. You know your times tables, right? Right? Right. Okay, let's do a few more. This time we'll go from exponents to radicals. So now, right, using radicals and simplify. So 64 to the 1/3 power. So I know that this is the cube root of 64. And 64 to the 1st power is just 64. We can write the 1st power if you want, but it's just 64. And the cube root of 64 is 4. 4 times 4 is 16, and 16 times 4 is 64. What about 4 to the 5/2 power? Well, we know that this is going to be 4 to the 5th. And then I left the index blank because, you might want to write this down as well, a blank index implies square root. Right? And you should know this because anytime you see that radical sign, you automatically think square root. So if there's no number here, that's a square root. If it helps you to write it, go ahead and write it. It's not wrong, right? So this is another case where it's going to be a lot easier to, in fact, take the square root of 4 first. So I'm going to move my 5 out here. We definitely know the square root of 4, that's 2. So 2 to the 5th power. And 2 to the 5th power is 2, 4, 8, 16, 32. We'll do one more to make sure you got the hang of it. $625 to the 3/4 power. So again, this is the same as the 4th root of 625 to the 3rd power, right? a fourth root of 625, and it's okay if you need a calculator for this one, but that's going to be 5. So this is 5 to the third power. And then 5 to the third power is 125. So that's going to conclude these video notes on rational exponents. Tomorrow you'll have video notes on equations with rational exponents in them. These rational exponents are really important because they help us expand what exponents are, and they're especially helpful when you get to calculus, and you'll see.